to question 1. Dia minta you state the differences between asynchronous and synchronous counter in terms of their clock connections, their flip-flop input, JK and D, and then their aliases. So this one you can find from my notes lah. Clock connections, this is the answer. For ripple counter, which is asynchronous, will allow some flip-flop outputs to be used as a source of a clock for other flip-flops. For synchronous, apply the same clock to all flip-flops. And then their aliases, okay, synchronous is ripple, synchronous is parallel. Flip-flop input JK ataupun D ataupun T, whatever types of flip-flop yang kita pakai lah. Normally kita pakai JK. So for JK, kalau kita tengok for asynchronous, J and Ks, all J, Ks input are 1. Okay, so semua input JK connected kepada 1. Kalau asynchronous, yang ni kita belum belajar lagi, tapi kita boleh tengoklah nota ni. Kita tengok J dan K dia datang bukan daripada 1, dia datang daripada output gate ni tadi. Okay, so you may find question 1 in my notes. Explain the term mode and the disadvantage of asynchronous counter. So ini pun dalam notes. Mode and flip-flops, modulus, MOD for modulus to the end counter. So MOD, mode, stands for number of states. Okay, so modulus bermaksud number of states. So in terms of counter, what is the counter cycle through X states? So kalau mode 10, maksudnya counter will cycles through 10 states. Okay, kalau mode 20, so 20 state. So modulus tu adalah states lah. And dia punya disadvantage of asynchronous, this lah. Okay, does not change states at exactly the same time as they do not have common clock source. So this will create this cumulative delay. Okay, itu dia punya disadvantage of asynchronous counter. So question 1 and question 2, you may find the answer from my notes. Okay, next we move on to question 3. So design the asynchronous counter using NGT JK flip-flops that counts in the following sequence. 0, 1, 2, 3 up until 13, back to 0, 1, 2, then dot dot dot. So meaning that it will count up until 13, back to 0, and then 1, and then 2. Then following up until sampai 13 balik lah. So this is a 0 until 13 up counter, or also can be called as a mode 14 up counter. Why 14? 0 until 13 obviously memang ada nombor 13 paling besar. But if you count the number of states, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it is a mode 14 up counter. Okay, so mode 14 up counter, the number will count until from 0 until 13, and the reset state will be state number 14 lah. So we don't want sekejap, ini betul ke? This is one. Okay, cuba. Saya rasa soalan dia ni saya dah ubah. Moment ya guys, tutorial. I'll try to simulate the circuit first before I share with you the solution. Okay, so 0 until 13. So let's count. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so this is the circuit lah. Alright, so this is D, this is C, and then this is B. Alright. So this is the correct circuit. Then this is the answer lah. This is how you design a mode 14 up counter, which will count from 0 until 13. So how do you design them? Likewise, how I have already explained to you last week. Okay, kita kena guna NAND gate dekat sini. Okay, so kalau kita tengok semua gate, okay, this one requires us to use NGT. So I'm using the flip-flops which have negative input of the clock. Okay, each of them. Alright, and then here we have the preset and clear ataupun set dan reset. So clear is the position where your output of the NAND gate should be connected to. Okay, the rest J, K and set ataupun preset ni connect them to 1. VCC masukkan kepada preset J dan K, preset JK, preset JK, preset JK. But the clear port is connected to the output of this gate. So what is this gate? Gate apa ni? NAND gate, where the input of this NAND gate should be the state, should be the temporary state of this counter. So you count until 12, 13 and then back to 0. So like I've already shown to you last week. Okay, so the temporary state will becomes, okay, saya guna yang ni. Tak boleh pula. Memang I'll use a new one lah. Okay, so the number will be going from 0 to 1, 2, 3, 4, 5, 6, 7, then to 8, 9, 10, 11, 12, 13. And then back to 0 lah. So this will be the sequence lah. Saya letak anak panah je lah. Saya nak lukis tu consume time. So this will be from 0 until 6 and then it will goes down here and then it will goes from 7 until 13 and then lastly 13 to 0. But like I've already told you, there will be a temporary state where this number 13 will goes to naturally. Okay, secara naturalnya selepas 13 nombor akan pergi ke nombor 14. Alright, then baru dia kita gunakan nombor 14 ni untuk resetkan dia supaya dia jadi kosong lah. So this is your temporary state. Okay, so after 13 naturally it goes to 14, but this will be your reset state to make sure that after 13 it will goes directly to 0. So 14 in binary is, okay, kalau ini 8, 4, 2, 1. So secara binary-nya dia akan jadi 8 tambah 4, 12, 12 tambah 2, 14, 1, 0. So 1, 1, 1, 0. Okay, let's say this is flip-flop D, flip-flop C, flip-flop B, flip-flop A. Okay, so 1, 1, 1, 0. So meaning that whenever the numbers, the counting sequence dekat flip-flop tu dekat D dia 1, C dia 1, B dia 1 dan A dia kosong, A ni tak kisahlah. Okay, as long as dia kosong ataupun 1, yang penting tiga-tiga ni adalah 1. Then we reset this number to become 0. Sebab tu saya ambil correction D, C dengan B. Okay, so if you look at my solution, so saya tarik satu daripada, this is D, okay, this is A, the LSB connected to the external clock source, up counter daripada Q pergi ke next clock, Q to the next clock, Q to the next clock. Okay, so this is D, saya masukkan ke NAND, this is C, and this last one is B. So whenever this is 1, 1, 1, here will become 0. Bila dia masuk sini dia jadi 1 sebab sini ada bubble. Okay, there is a bubble there. So bila sini triggered to becomes high, maksudnya dia clear. Whenever this flip-flop clear, dia akan jadi 0, 0, 0, 0. Okay, sebab masa tu, the number is 1110. But whenever the number is 1110, dia akan masuk 111 through this NAND, then dia masuk dekat clear. Every each of these 4 flip-flop will be cleared. So dia akan jadi daripada 1110 to become 0000. So that is how you obtain this counter lah. Right, and then the output connected to the LED or 7 segment, then dia akan kira lah. Dia akan tunjuk lah, this is in the binary form lah. So this is basically number 3, okay. 8, 4, 2, 1. 2 menyala, 1 menyala. So 2 tambah 1, 3. Itulah, okay. Tapi I can prove it by my circuit tadi. Okay, so yang ni saya guna 7 segment, senang sikit nak tengok. So if you run, dia akan kira lah. 5, 6, 7, 8, 9. Okey, lepas 9 dia akan kira dalam decimal, dia akan keluar A, B, C, D, E, F. So 4, 5, 6, 7, 8, 9, A, B, C, D, then back to 0. Okey, E tu dia masuk sekejap tapi dia reset. So it needs to be specifically designed lah, baru you boleh dapat. Okay, kalau benda ni tak ada, there are no connections to the clear. Clear ni you connectkan kepada VCC, then dia akan count up until full cycle 4 bits lah, 0 until 6 sampai 15. Okay, we look to the second one, 0 up until 7, then back to 0. So this is mode 8 lah. Ada 8 state, 1, 2, 3, 4, 5, 6, 7, 8. So mode 8 up counter. Okay, so mode 8 up counter is a full sequence counter lah. Okay, so bila dia full sequence counter, you tak perlu menggunakan NAND gate tu. All of the J, K, preset dan clear ataupun set dengan reset ni, you connectkan kepada VCC. Okay, ni 3 VCC, bawah ni pun clear, saya connectkan semua kepada VCC. So kalau saya runkan, then okay, this is the same circuit lah. Okay, bila saya run, dia akan kira sampai 7, balik kepada kosong lah. Full cycle maksudnya, from 000 sampai 111. That is known as a full cycle 3-bit up counter. Okay, 5, 6, 7, balik kepada kosong. Okay, so that is pretty straightforward. Clock source only to the LSB. The second clock datang daripada Q yang sebelumnya. Third clock datang daripada Q yang sebelumnya. All of the output connect them to LED ataupun 7 segment. And then J, K, preset and clear, connect them to VCC. Then you dapatlah dia punya output. Okay, next one is 3210. 3210. So down counter 3210. So 3210, we have to determine the number of flip-flop to be used. Punca kuasa 3, square root of 3, kita akan dapat around 1 point something lah. Okay, square root of 3, punca kuasa 3, 3 square root, dan kita akan dapat 1.7. So meaning that we going to be needing 2 flip-flops lah. Or you can determine by, kalau kita tengok 0, 1, 2, 3, 3, 2, 1, 0. So there are 4 numbers, 4 states. So bila you perlukan 4 state, punca kuasa 4 sama dengan 2. So you pakai 2 flip-flop. But this is a down counter. Alright, so first flip-flop, the LSB flip-flop datang daripada output source. Second flip-flop datang daripada Q bar, not from Q anymore. Sebab down counter. So always remember that. Down counter comes from Q bar, up counter comes from Q. Okay, all J and K's, preset and clear, connect them to the VCC, and then the output of Q, each of the flip-flop, connect them to LED. You runkan, dia akan kira secara terbalik. Okay, so this is known as a full cycle 2-bit down counter. Okay, sebab dia kira penuh. For 2 bits, you have only possibilities of 00, 01, 10 and 11. So 11 adalah 3. Okay, so 0, 1, 2, 3, 0, 0, 0, 1, 10, 11. Then dia patah balik ke 0. So, it is a full cycle lah. Sama macam B ni tadi, full cycle. So, bila saya simulate, saya akan dapat output as attended lah. 3, 2, 1, 0. 3, 2, 1, 0. So, meaning that the connection is correct lah. Okay. Then we move on to number 4, design the asynchronous counter listed below. Mode 7 up counter using NGT JK flip-flop. So mode 7 means that you will be counting from 0 until 6 only. Mode 7 ada 6 state, ada 7 state, starts from 0, you end at 6. Okay, so meaning that kalau ikut daripada diagram ni tadi, kita akan kira nombor dia akan berubah lah. 4, 5, 6. State. Okay. So this is the reset state. So this is the state diagram. Dia akan count 0, 1, 2, 3, 4, 5, 6. And then back to 0. So that is the sequence. Tetapi secara naturally after 6 untuk this is 3 bits lah. Okay, sebab sampai 6 it is still 3 bits, iaitu 110. 110, the next bit that naturally should be is 7. Sepatutnya lepas 6 dia pergi ke 7. So that means that 7 will becomes the reset state. So 7 in binary is 111. So meaning that whenever C, B and A's are 1, then dia akan resetkan nombor ni kepada 0. So dia masuk jam 4, 5, 6, dia masuk temporary sekejap 7 ni. Okay, dia masuk sekejap 7 ni. And then dia reset, sebab 111 dia reset masukkan kepada 0. So nombor 7 ni tak keluar pun, sangat sekejap. So this is the design lah. Right. So preset JK, preset JK, preset JK of all the 3 flip-flop saya connectkan kepada VCC. First flip-flop, clock come from the external input, clock source. And then yang ini datang daripada Q, yang ini datang daripada Q, because it is an up counter. 0 sampai 6 balik kepada 0. So saya tarik ni satu daripada C, second one from B, third one from A, and then connect them to each of the clear. Okay, saya connectkan kepada setiap clear. Then whenever it is 111, clear akan trigger jadi high, so automatically dia jadi 000. So saya boleh tunjuk dekat sini. Okay, this is mode 7 up counter. 0, 1, 2, 3, 4, 5, 6, back to 0. Okay, 7 tu tak sempat keluar pun. Dia masuk sekejap, terus dia reset, jadi 0. Right, so that is how you design them lah. Okay, so that is for 4A, mode 7 up counter using JK flip-flop, NGT JK flip-flop. So pakai NGT bubble kat depan. So mode 7, same way, how do you determine the number of flip-flops? Ada 7 state, so punca kuasa 7. Square root of 7. 7 square root, it is 2.6, meaning that you'll be needing 3 flip-flop lah. Mana kita boleh pakai 2.6 flip-flop? Kita kena pakai 3 flip-flop, nombor bulat. 3 bits down counter using PGT JK flip-flop. Okay, so for this one, 3 bits down counter. So dia maksudnya nombor dia terbalik lah. So instead of this number, 3 bits maksudnya full cycle. So when it is full cycle, maksudnya dia akan kira semua nombor yang ada dalam 3 bit. So 3 bit daripada 0 adalah 0, 0, 0. Okay. Okay, itu untuk 0. So 0, 0, 0 sampai 1, 1, 1 lah. So the sequence akan jadi terbalik sebab down counter. Okay, this one will goes up. This one will go to the other way around. And then this one will goes down. Okay, so 07654321076. So dia calculate pusing macam ni. So obviously dia full cycle lah for 3 bits. Okay, so the design of the circuit will be okay. Question pakai PGT Okay, yang ini sebab dalam software yang saya pakai tu, saya cari yang PGT mula-mula tak jumpa, so saya pakai je NGT, tapi saya terangkan kat sini. For these two questions, please change the flip-flops clock input to PGT. Maksudnya dekat sini bila you draw nanti dalam you punya final exam ataupun dalam you punya lab, make sure kalau PGT tak ada bubble ni lah, delete bubble ni. Okay, so it is a 3-bit full cycle down counter. So first flip-flop clocks input from the output source. All J, K preset and clear, connect them to 1. Second flip-flop clock comes from Q bar. Third flip-flop clock input comes from the second flip-flop Q bar output. Sebab dia down counter. Alright, so bila you simulate, gunakan LED ataupun gunakan 7 segment, it will count reverse lah for 3-bit 3-bit punya counter. So I'll show you my circuit. Okay, this is the same circuit. Saya ubah je sebab dalam diagram ni saya pakai 7 segment, senang nak kira. Okay, tetapi bila you do case, you kena letak LED sebab for education purposes, kalau letak ini, then kita tak tahu macam mana nak baca. 7, 6, 5, 4, 3, 2, 1, 0, back to 7. Okay, so meaning that this circuit is correct lah. Okay, so no gates at all, tak ada gate apa-apa, cuma connectkan clock tu betul, positif ke negatif output. Okay, katakan saya ubah saya ubah ni pergi ke daripada Q, saya tak nak daripada Q bar. Okay, so dia akan count terbalik lah, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. Kalau ambil dari Q bar dia terbalik, 7 balik ke 0. Okay, and then next one is mode 11 up counter using PGT. So sama juga using PGT. Mode 11 meaning that it will count from 0 until 10. Okay, so 3, 4, 5, 6, 7, 8, 9, 10. Let's see. So okay, so obviously this counter needs temporary state lah. Sebab apa dia perlukan temporary state? Sebab dia bukan full cycle. Okay, so this is how the counter should look like lah. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 baik tu. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 state. Okay, mode 11. So, guna calculator, 11 square root, then you need 3.3 flip-flop. So, 4 flip-flop lah kita pakai. Okay, so naturally, after 10, the number should goes to 11. So, bila dia pergi ke 11, that means that is the 11 will be the temporary state. Okay. Okay, disebabkan oleh itu, kita kena reset nombor 11. Where naturally, 11 adalah 8, 0, 1, 1. Okay. 8 tambah 2, 10, 10 tambah 1, 11. So, we need to reset DB, kita perlukan input DB8 need to becomes 1 for the flip-flop to be reset to 0, 0, 0, 0. Okay, so D, B and A. So, tengok saya punya solution. So, this is the same Dia soalan guna PGT. So, ini pun guna yang tak ada bubble. So, I pull one from D. I pull one from B. I pull one from A to become the input of this 3 input NAND gate. And connect the output to each of the clear ataupun reset punya port. J, K and preset connectkan kepada VCC. Clock source, only the LSB comes from the output source. Next flip-flop comes from the first flip-flop. Third flip-flop comes from the second flip-flop. Fourth flip-flop comes from the third flip-flop. Each queue connect them to the LED. Then dia akan count lah nombor 0 sampai 10. Okay, let me show you betul atau tak. So mode 11 up counter. Then I'll run. Kenapa ni? 2, 3, 4, 5, 6, 7, 8, 9, 10. Then patah balik kepada 0. Okay, mode 11, it will count until 10. 10 is displayed as A dekat dalam 7 segment. A itu huruf A. Okay. 6, 2, 8, 9, 10. This is A, huruf A besar. A besar is 10. Then dia akan count balik pada 0. So, betul lah connection tu. So, D, B dengan A masuk dan connectkan kepada clear. Okay, so last one for today for asynchronous mode 16 down counter. So mode 16 kita square rootkan 16, kita dapat 4. So mode 16 obviously it is a full cycle counter lah. 0, 0, 0, 0 up until 1, 1, 1, 1. So mode 16 dia akan kira 0 sampai 15. Okay, so ini you boleh adjust sendirilah. Okay. 6 then goes to 7 then goes to 8. Saya buat ni 12, 13, 14, 15. Okay, so there will be no temporary state at all sebab dia adalah full cycle. Okay, so I'll drag this one a little bit here. So this is a full cycle 4 bit. So you're going to be needing 4 count flip-flops. So this is the sequence lah. Zero, 7, 8 until 15 back to 0. So tak ada reset state, yang ni boleh delete lah. So just draw a full 4-bit counter. But it is a down counter betul tak? Okay, down counter. So 4-bit down counter. So I'll draw 4 flip-flops. Not this one. Sorry guys. Okay, this one. 4 flip-flops. Yang ini datang daripada output source. Second flip-flop from Q bar, third flip-flop from Q bar, fourth flip-flop from Q bar. J, K, preset and clear, connect them to VCC. Each Q connect them to LED ataupun segment. Runs them, dia akan dapat sequence yang kita nak lah. Next one ni dia dah, ini adalah synchronous, kita belum belajar lagi. So let me show you down counter untuk 4 bit. Okay, so F, E, D, C, B, A 987 65 43 210 15 14 13 12 11 10 9 8. Okay, so dia count ke bawah lah. Okay, so meaning that the counter is correct. Okay, yang ini NGT, so pakai bubble ke depan. Okay, kalau saya ubah clock E ke Q, output Q yang positif, then dia akan jadi terbalik lah. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and then back to 0. Okay, so itu beza down counter dengan up counter. So to design them, they are very easy, especially for synchronous, sebab it is very straightforward. You hanya perlu congak sama ada dia perlu reset state or not. Okay, meaning that yang temporary state tu, does it need or not? So if it is a full counter, then you don't need the reset state. If it is not a full counter, then you need to determine the number of flip-flops. And then, what are the states to be reset? The next state lah, after the greatest number yang paling besar. Katakan nombor, kalau kata 0 sampai 10, so reset state dia adalah 11. Okay, so kalau 0 sampai 3, reset state dia adalah 4. Itulah.